Good evening, everyone. Today we're going to be looking at the theory of intermolecular forces. And to start off, we're going to talk about effectively the weakest of these forces, which is the van der Waals force. Now, just to motivate this a little bit, we have actually two atoms, nucleus and electron density surrounding them. With any significant separation and with no net charge, there would be no significant force acting between them. But if the two neutral atoms are brought such that the separation distance is approximately 6 angstrom, we'll start to see an attractive force between the two atoms. And if we get even closer than that, to the point where the two electron densities will start to overlap, we will get a repulsive force between them. So let's take a look at, in a little more detail, what an equation for that interaction would look like. So we can write down the potential that approximate this interaction, which would be the Lennard-Jones potential. And I'll just write its functional form. So we can say this interaction is proportional to two terms. The first, which is a repulsive term, goes like 1 over r to the 12th. And then we have an attractive term that takes over at larger distances, that goes as r to the 6th. So the question is, where do these two terms come from? Now the first, as we may have mentioned, it has to do with the overlap, and it has to do with the Pauli exclusion. You cannot have two electrons existing in exactly the same quantum state. And so at very small distances, this force takes over. Now you may wonder, where does this 12 come from? This particular functional dependence is only an approximation. Since there is no good form of this, it's just a very strong force. So this number was chosen just to be much larger than r to the 6th at very small distances. Now this smaller term, it's attractive, has to do with charge interactions, and in particular small dipole moments that may exist. More generally, multipole moments that might exist. So higher order poles, such as quadrupoles, that can instantaneously form within the charge density. So you have the electron density. You may instantaneously have a dipole oriented this way, which could then induce a dipole on the other atom, resulting in a momentary charge attraction between these two. So that's really our starting point for this force. And we'll dig into the mathematics a little bit more next time.